Hello, it's Gareth from Neuralispect, and today we're going to talk about how you can make better decisions with AI using what I think is kind of an overlooked and little known technique that really produces some very powerful information that you can use to help within your organization to make strategic decisions. Now we're going to start off talking about models because models are everywhere. We have computer vision models, we have natural language processing models, we have forecasting models, we have prediction models, we have models coming out of our ears, and yet do we actually properly understand what they are? Because I don't think we do. And personally, when I think of a model, I think of my 10-year-old self with an Airfix kit and lots of glue making a little tiny bit of plastic that looks like a Spitfire. And once you've done it, you put it together, then you can see that it has wings and it has undercarriage and it has a cockpit, and you can zoom around your bedroom like you're in, the Battle of Britain or something. But the point is that it represents and clearly represents something that actually flies in the air. It is a representation of a physical object. And that's what I think of being a model. And I think that we could apply the same sort of approach to machine learning models. And if you think about it, there are certain types of models where that is fairly true and obvious. So, for example, we know that we can use machine learning to help us with autonomous vehicles. They can make decisions about how to drive. So that type of model, you might say, it emulates a driver. We know also that we can make machine learning models that are capable of finding defects or breaks or cancerous growths in x-rays. And those types of models, well, they would emulate like a radiographer. And we also know that we can make pretty damn good models that are capable of playing games like chess and Go. And those types of models, well, they emulate a chess master or a grand Go master, I suppose. I don't know. So the point is that machine learning models, they can emulate very clearly other things, other people. But in the world of business and maybe sales and marketing, then we use machine learning models a lot, but do we really kind of think of them in that same way? Well, no, not really, but nevertheless, they still represent other things. They might be more sort of process driven. We're interested in models that are capable of understanding the health of opportunities or how much money to spend on a particular marketing channel and things like that. But they effectively, encapsulate the knowledge of an individual person playing a role inside that type of organization. And that's how I think that we should be thinking of all machine learning models, because they can be used in that way. They all represent a thing, whether that's a physical thing or more of an abstract thing. Now, the cool thing about models is that you can play around with them a little bit. So my Spitfire, you can paint that pink and put a big Barbie sign up the side of it and see what it looks like and think, oh, that looks quite nice actually. I might keep it like that. And the good thing is you don't have to do that with the actual 1940 priceless aircraft. You can do the same thing with autonomous vehicles. The vehicle doesn't actually have to be physically moving for an autonomous vehicle to be driven by its machine learning brain. You could, all you really want to know is it has these sensors that are looking at some sort of input, like a video or something, and it's what we want to do is to be able to monitor how it behaves when it has inputs that like simulate somebody crossing the road. We want to see that it's actually stepping on the brake pedal. The car doesn't actually have to be in motion and traveling at 70 miles an hour down the road for us to be able to test that. We can now do that in a simulated environment. So we know that we can already do this in sort of much more physical world type models, but how can we do this inside a business environment? Well, very easy, and we use the same type of approach. So let's just take my very sort of go-to type of model, the sort of the Deal Health model, and think about, well, how can we use that to simulate things? Well, what we could do is we could say, what if we want to find out how likely that opportunity would be to win if it was being managed by a different sales rep. So all we need to do is, for us to be able to do that, is use our input, which is going to be the representation of our opportunity, and we're going to swap out the name of, I don't know, Joe Schmo for Sarah Smith, and see what the difference is between the deal health that comes out the two. So when it has Joe Schmo working on it, the deal health model might say, well, it's only 80%. But when Sarah Smith comes in, well, she's really great. We'll put her up to like 95%. So there is this quantifiable difference between the two. And you could do that with any attribute that the model has been trained on, lead source, or the particular industry, or the amounts, or the stage that it's in, whatever. Anything the machine learning model understands, you can play around with. So we can start to answer a whole raft of what if type questions, and then start using that to make decisions about what we're going to do on individual opportunities. But there's more. And the more is, we can use this same technique to guide recommendations, because we don't just have to swap out Joe Schmo for Sarah Smith. We could test to see what the difference is for all of the reps that we have available for this one opportunity. And we can say, okay, let's not just use Sarah Smith, but let's use everybody, and we'll ask the model separately how likely that opportunity is to be won, and when we pass in every single sales rep into that opportunity. And then we'll end up with this sort of big leaderboard of how likely this one opportunity is going to be won by all of your sales reps. And so based on that, we can then make a recommendation of, actually, the best person to be managing this deal is that person, because they're at the top of the leaderboard, and we have to sort of figure out what other constraints they're operating on, their capacity and all that sort of stuff. But that's the general principle of it, right? So, we can now have a recommendation system where if we now have a opportunity that comes in, then we can just ask our model, who's the best person that we should be assigning to this particular opportunity that we've got coming in? So that's recommendations. But we can go even further, and we can say, what we want to know is how different are the outcomes of various attributes that we're kind of interested in. Now, I've said a lot of words there, so let's just unpack that a little bit. And I'll try and use an example. I will still stick on the deal health, but we'll just tweak it a little bit, and we'll say, what we're interested in knowing is, what is the difference between the lead source on this particular, on our operation. So we might have, let's just pick two, referrals and cold calling. So opportunities which are the result of a referral, we suspect, might be more easier to close. We might have more success closing them than an opportunity where the source came from a cold call. But we don't know that for sure. It might just be that we can run some very simple statistics and be able to see that the win rate for referrals is significantly higher than it is for cold calling. But maybe there is some other condition at play that means that just naturally the types of opportunities that result from referrals are more likely to be won anyway. We don't know. So what we really want to kind of understand is, what is sort of an unbiased assessment of how the two lead sources compare against each other. And so the way to approach this is to say, much the same as we did with the recommendations, we can use each lead source and use that as the input into our model and ask it, how likely is it for this opportunity to be won by this lead source of referral? Or how likely is it for this opportunity to be won when it's from a cold call? And that's going to give us one answer for that one opportunity, and we'll see what the difference is. But then we've only got one data point, and we can't generalize that out for all opportunities. We can only say that's true for this one opportunity. So what we really need to do is to use this same approach of using all of your lead source values, but apply it to lots of opportunities. So if we had a big data set of all of the opportunities that we've worked on in the past, and then we could use that same approach and say, okay, what we're going to do is we're going to change the lead source value from whatever it was previously to be referrals for this whole massive set of data, and then we're going to put that to the machine learning model and ask it to make predictions on each of those opportunities, and then we can do some sort of aggregation to tell us, okay, so for the referral lead source, on average, your win rate is 65%. But when you do that same thing for referrals, so we take our big data set and we change all of the lead source values to cold calling, then on average, the machine learning model thinks that your win rate is 55%. So there is a delta between the two. And so that tells us, how effective different lead source channels are to your sales operation. And again, we don't have to just use it for lead source and opportunities being one. We can use it for different marketing channels or for different lead nurturing type approaches and things like that. So there is a whole wealth of information that we can mine out of these systems if we just think a little bit more laterally. So really cool. Hope you enjoy that. I'll see you next time. Thanks. Bye.